Problems involving quadratic function. On the next examples of problem involving quadratic function, remember this. Free-falling objects can be modeled by a quadratic function. H of t is equal to negative 4.9 t squared plus v sub 0 t plus h sub 0, where h of t is the height of an object at t seconds when it is thrown with an initial velocity of v sub 0 meter per second and an initial height of h sub 0 in meters. If the units are in feet, then the function is h of t is equal to negative 16 t squared plus v sub 0 t plus h sub 0. Example 5. On top of a hill, a rocket is launched from a distance 80 feet above a lake. The rocket will fall into the lake after its engine burns out. The rocket's height h in feet above the surface of the lake is given by the equation h of t is equal to negative 16t squared plus 64t plus 80, where t is the time in seconds. What is the maximum height reached by the rocket? Equation of the quadratic function is h of t is equal to negative 16t squared plus 64 plus 80. So transform the equation in standard or vertex form. So I use here the completing the square method. I factor out the negative 16, and then what we left inside the parentheses is t squared minus 4t. Then outside the parentheses plus 80. Then get the half of 4, so that is 2, and then square it. The answer is 4. And this 4 will be multiplied by a, which is negative 16. So 4 times negative 16 is equal to negative 64. Yung 4 ay i-add sa loob ng parentheses, while yung negative 64 is subtracted outside the parentheses. So the equation will be now h of t is equal to negative 16 times the quantity of t minus 2 squared. Yung pst ay ginawa ng square of binomial, and yung 80 minus negative 64 is positive 144. This is already the standard or vertex form. So let's get the vertex. The vertex is 2, 144. So it means that yung 2 is referring to the time, and yung 144 is the maximum height. So it takes 2 seconds to reach the maximum height of 144 feet. Example 6. A ball is launched upward at 48 feet per second from a platform 100 feet high. Find the maximum height the ball reaches and how long it will take to get there. So for the solution, let us write the given. The given initial velocity is 48 feet per second. And then for the initial height, that is 100 feet. Substitute this in the quadratic function. H of t is equal to negative 16t squared plus v sub 0 t plus h sub 0. So h of t is equal to negative 16t squared plus 48t plus 100. Then change this into vertex form to get the vertex. So I will use the completing the square method. Factor out the a, which is negative 16. So inside the parentheses will be t squared. 48t divided by negative 16 is negative 3t. And then plus 100 outside the parentheses. Get the half of negative 3 and then square it. So the answer is 9 over 4. Add this 9 over 4 inside the parentheses. And then yung 9 over 4 multiply by the value of a, which is negative 16. So cancel negative 16 and 4. So negative 4. 9 times negative 4 is negative 36. Subtract negative 36 outside the parentheses. And then Simplifying the equation, h of t is equal to negative 16 times the quantity of, transform the PST in square of binomial, so t minus 3 over 2 is squared. Then outside the parentheses, 100 minus negative 36 is positive 136. So the vertex is at 3 over 2, 136. So this 3 over 2 is the time, and then yung 136 is the maximum height. Therefore, our final answer in here will be the maximum height is 136 feet, and it will take 1.5 seconds to get there. So that ends the problem solving involving quadratic function.